let's say a cylindrical body, and you extend it, right? You apply a tensile force. What happens is that the diameter reduces of this body, right? So mainly because to keep the volume constant, all that is fine. But the ratio of how much the diameter changes and the ratio of how much the length changes is a constant, right? And it's called the Poisson's ratio. So basically, let's say the length increases by delta L and the diameter reduces by delta D. Poisson's ratio equals minus delta D by D divided by delta L by L. Now, why the minus? Again, it's pretty simple, right? Because in this case, when you're pulling it, right, that means delta L is positive. And obviously, at that point, the diameter will only reduce, so delta D will be negative. So therefore, to make the whole ratio to make the whole ratio positive, you add a negative sign, therefore it becomes, the Poisson's ratio is always positive. This is true even when you compress it. So when you push it inward, right, delta L reduces, so delta L will be negative, but your D or diameter will increase, right? So delta D will be positive. So again, if you add just one negative sign, the whole ratio becomes positive again.
Types of potential energy. Elastic potential energy. Objective. To understand elastic potential energy as a type of potential energy. Energy is the capacity to do any work. Potential energy is a form of energy that an object possesses by the virtue of its position. Another way to think of it is as stored energy that has the potential to do work. Potential energy can be one of three types: gravitational, elastic, or chemical. Our focus for this session will be on elastic potential energy. Elastic potential energy is the energy that is stored in elastic materials and objects such as springs and rubber bands. If we compress a spring, the force we apply to it will be stored in the spring as elastic potential energy. Once we move our hand, the stored energy will be released, helping the spring bounce back and return to its original position. We can observe a similar phenomenon when we stretch a spring. The stored elastic potential energy will help it restore its original position once we release it. A stretched rubber band also acquires elastic potential energy. The further it is stretched, the more potential energy it has. Let's look at a bow and arrow. When the string of the bow is pulled, the bow, which is made of a flexible material, will bend and store energy. Once the string is released, the energy will also be released, launching the arrow. The further back the string is pulled, the more the bow will bend, allowing the arrow to travel even further once the string is released. Summary. Energy is the capacity to do any work. Potential energy is the energy that an object possesses by the virtue of its position. Potential energy can be one of three types: gravitational, elastic, or chemical. Elastic potential energy is the energy that is stored in elastic materials and objects such as springs and rubber bands.